Ever wish you could, like, multiply your computer's hardware, like have one network card and make it do the work of 256?
Wow.
That's the kind of superpower we're diving into today
Mm.
with RI Alternative Routing ID.
Right.
And we've got this fascinating technical document called Understanding Alternative Routing ID in PCI Express. PCIe,
Okay.
to guide us through this.
Cool.
So get ready to unlock a secret world inside your computer.
Uh-huh.
The one that keeps things running smoothly, especially with all the demands we put on our devices these days.
It's amazing how RE tackles a very real limitation.
Okay.
You know how PCI Express used to assign a digital address to every device?
Right.
Well, it was like a tiny apartment building with only 8 units.
Okay.
As computing got more complex, especially with virtualization needing tons of virtual devices,
Yeah.
we were running out of room fast.
So RAI swoops in with a major renovation.
Yes.
But how do they make room in this crowded digital building?
Imagine if those 8 apartments could suddenly hold 256 residents each.
Wow.
That's essentially what ARI does.
Okay.
Instead of limiting the number of functions,
Uh-huh.
think of those as the tasks a device can handle.
Right.
ARI lets one physical device manage a whopping 256 functions.
Okay.
It's a game changer for efficiency.
So that's a huge increase.
Yes.
But how does this magic actually work?
Right.
It can't just be rearranging numbers.
No, it's more like a clever set of rules everyone agrees on.
Okay.
First, any device or port that's ARI capable announces it.
Okay.
It's like putting up a sign saying, hey, I can handle the big leagues.
Got it. So it's letting the whole system know it's ready for more action.
Yes.
Then what?
Then instead of using the old address system that limited things, these ARI devices start using an expanded set of function numbers.
Okay.
It's like they're moving into those brand new apartments within the same building.
Okay, cool. But doesn't that cause confusion for everything else trying to communicate with it?
That's where ARI gets even smarter.
Okay.
The downstream ports, like the switches and root ports, have to play along too.
Right.
If they support ARI forwarding, they're basically told, ignore those old address limitations. These devices are playing by new rules.
Uh-huh.
It keeps everything flowing smoothly.
Ah, so it's a system-wide upgrade.
Yes.
But wouldn't managing 256 functions be incredibly complex?
Right.
Like herding cats, almost.
That's where ARI uses a system of function groups.
Okay.
Kind of like organizing those 256 residents into different departments.
Okay.
This helps with access control and makes sure the right data gets to the right function,
Right.
preventing any digital chaos.
Okay, so RRI isn't just about expansion. It's about smart management, too.
Uh-huh.
I'm starting to see why it's so important.
Yeah.
But let's get out of the technical weeds for a second.
Right.
What does this actually mean for how we use and experience technology?
Well, ARI has its fingerprints all over modern computing.
Okay.
It's especially huge in virtualization,
Uh-huh.
which is like running multiple virtual computers on a single physical machine.
Right, like having multiple operating systems on one computer.
Exactly. ARI is the foundation for something called SRIOV,
Okay.
which lets a single physical device, like a network card, act as multiple virtual ones.
Okay.
It's like taking that one network card and giving each virtual machine its own private slice.
So each virtual machine thinks it has its own dedicated hardware.
Yes.
Even though they're all sharing one physical device.
Yes.
That's pretty clever.
Yeah.
What are the benefits of that kind of setup?
It's a huge boost for both performance and security.
Okay.
Each virtual machine gets its own dedicated resources, so there's less fighting over bandwidth and less risk of one virtual machine snooping on another's data.
So ARI is like a virtualization superhero.
Yes.
I can see why this would be a game changer for things like cloud computing, where tons of virtual machines are running at once.
Absolutely. But ARI's impact goes way beyond just virtualization.
Okay.
It's also essential for managing complex topologies, those intricate webs of interconnected devices inside modern computers.
Right, we're not just talking about one network card anymore.
No.
There are CPUs, GPUs, storage controllers,
Yes.
and all sorts of other devices talking to each other.
Right.
It sounds like a recipe for a communication meltdown.
That's where ARI steps in again.
Okay.
With its expanded function numbers, ARI provides a much more comprehensive addressing system for all those devices.
Uh-huh.
It's like having a detailed roadmap for data, making sure everything gets to its destination quickly and efficiently, even in the most complicated setups.
Okay, so ARI is like the air traffic controller of the PCIe world.
Yes.
Keeping everything flowing smoothly, even with all those extra flights coming in and out. I'm starting to grasp just how essential ARI is for modern computing.
Yeah.
But what about high-density systems like data centers, where space and resources are at a premium?
Right.
How does ARI help there?
Think of it this way. ARI allows you to squeeze more functionality out of the hardware you already have.
Okay.
Instead of needing a separate physical device for every task, You can have one device handling multiple functions thanks to ARI.
Uh-huh.
It's a lifesaver for data centers where space and power are limited.
It's like turning one room in your house into a multi-purpose space.
Yes.
Office, gym, guest room are all in one.
Right.
RRI really is a space-saving champion, isn't it?
Yes.
But all this talk of complex systems and data centers is getting a bit abstract.
Uh-huh.
Can we bring it down to earth with some real-world examples?
Of course.
Okay.
Let's start with something we all use.
Okay.
Network interface cards, or SAICs.
Okay.
Those are the things that connect our computers to the internet.
Yeah, I know those. They're like the doorways to the digital world.
Exactly. With ARI, you can take one physical NIC and split it up into multiple virtual NICs.
Okay.
Each one assigned to a different virtual machine.
So it's like having multiple separate internet connections, even though there's only one physical card.
That's a great way to put it, and it's incredibly useful for security and performance in virtualized environments. Now, each virtual machine gets its own dedicated network resources, so there's less risk of interference or snooping.
So it's like having separate lanes on a highway.
Yes,
Less traffic jams and smoother travel.
exactly.
I'm seeing how ARI really makes a difference in everyday computing. But what about other devices? Are there any other examples that would bring ARI to life?
Absolutely. Let's talk about storage controllers.
Okay.
These are the devices that manage how data is stored and retrieved from hard drives and other storage devices.
Right. They're like the librarians of the computer world, keeping track of all those digital books.
That's a perfect analogy. With ARI, you can have multiple virtual machines sharing one physical storage device,
Okay.
each one with its own dedicated virtual storage controller.
So it's like dividing up a library into multiple virtual reading rooms, each one with its own librarian and access to a specific set of books.
Precisely. This is incredibly efficient for data centers and cloud environments because it allows them to share expensive storage hardware without sacrificing performance or security. It's a win-win for everyone involved.
Okay, so ARI is bringing efficiency to data storage as well. Any other examples that would help us understand how ARI impacts the devices we use every day?
Let's not forget about GPUs.
Okay.
These are the powerhouse processors that handle graphics-intensive tasks like gaming, video editing, and even artificial intelligence.
Right, they're like the visual artists of the computer world, rendering all those stunning images and videos.
Exactly. And with ARI, you can assign dedicated GPU resources to different virtual machines,
Okay.
just like we did with a network card and storage controller.
So it's like giving each virtual machine its own personal art studio, complete with all the tools and resources they need to create amazing graphics. Why is that important, though?
This is huge for applications that rely heavily on GPU power.
Okay.
Imagine playing a graphically demanding game on a virtual machine.
Right.
Without dedicated GPU resources, the game would run slowly and the graphics would be choppy.
Yeah, that wouldn't be a very enjoyable gaming experience.
But with ARI, each virtual machine can access the GPU power it needs for smooth, seamless performance.
Okay.
It's like having your own private gaming rig in the cloud. And it's not just about gaming.
Right.
This is also essential for fields like artificial intelligence and scientific research, which require massive amounts of GPU power for complex computations and simulations.
Okay, so ARI is enabling all sorts of cutting-edge technologies. I'm starting to see just how far-reaching its impact is.
Yeah.
It's clear that ARI is this incredible powerhouse, silently working behind the scenes to make our computers more efficient, powerful, and flexible. But how does all this actually get implemented? What are the nuts and bolts of making ARI work in the real world?
Implementing ARI involves a delicate dance between hardware and software,
Okay.
with each element playing a crucial role.
Uh-huh.
On the hardware side, it all starts with PCIe switches.
Okay, PCIe switches. Remind me what those are again?
Think of them as the traffic directors of the PCIe world.
Okay.
They're responsible for routing data packets between different devices on the PCIe bus.
Uh-huh.
And with ARI, these switches have to become even smarter.
Smarter in what way?
Well, they need to be able to recognize and handle those extended function numbers that ARI uses.
Okay.
Instead of just looking at the old limited addresses, they need to understand the new expanded addressing scheme that ARI introduces.
Okay.
It's like upgrading the traffic signals in a city to handle a much larger volume of cars.
Oh, so they're like ARI-aware traffic cops,
Yes.
making sure all the data packets get to the right destination, even with all the extra traffic.
Right.
What other hardware components are involved?
Another crucial piece of the puzzle is the root complex, which sits at the very top of the PCIe hierarchy.
Okay.
It's like the control center for the entire PCIe system.
Okay, the root complex is the boss calling the shots.
Exactly. And with ARI, the root complex also needs a major upgrade.
Okay.
It needs to be able to configure and manage AI-enabled devices, making sure they're properly identified and integrated into the system.
So the root complex needs to be area-aware as well?
Yes.
It's like giving the control center a new set of blueprints for the upgraded city?
Precisely.
I see. So it's not just about having area-capable devices, it's also about having the infrastructure in place to support them.
Exactly.
What about the devices themselves? What needs to change on their end?
The devices themselves, which we call endpoints, also need to be modified to support AI.
Okay.
This involves adding some extra logic and configuration space structures to their hardware
Okay.
so they can speak the language of area.
So it's a collaborative effort involving all the different hardware components working in harmony.
Yes.
It's impressive how much engineering goes into making something like AI a reality.
Yeah.
But what about the software side of things? What needs to change there?
On the software side, the first thing we need are area-aware device drivers.
Okay. Area-aware device drivers, those are the little pieces of software that allow your operating system to talk to specific hardware devices, right?
Exactly. And with AI, these device drivers need to be updated to understand those expanded function numbers.
So they need to be able to speak RIEs.
That's a great way to put it.
What other software changes are needed?
Well, if you're using virtual machines, which you probably are if you're taking advantage of AI,
Right.
then your hypervisor also needs to be area-aware.
Okay.
The hypervisor is the software that manages your virtual machines, and it needs to understand how to allocate those virtual functions to different virtual machines.
So it's like the hypervisor is the city planner deciding which residents get to live in which apartments within those expanded buildings.
That's a great way to visualize it.
Okay, cool.
And lastly, your operating system itself needs to be updated to support AI.
Okay.
It needs to be able to recognize devices with extended functions and manage them accordingly.
Okay, so it's a whole ecosystem of software working together to make AI reality.
Yes.
It's amazing how much coordination is required across all these different layers of technology.
Yep.
This is all incredibly fascinating.
Oh.
But it's also a lot to take in.
I know it could be a bit overwhelming.
Yeah.
But don't worry.
Okay.
We're going to unpack all of this in more detail as we continue our deep dive.
That's good to hear. I'm already eager to learn more about how ARI is implemented in specific devices and systems.
Okay.
But for now, I think we've laid a solid foundation for understanding what ARI is, why it's so important, and the key challenges involved in making it work.
I agree. We've covered a lot of ground in this first part of our deep dive.
And there's so much more to explore. Stay tuned for the next part of our deep dive, where we'll delve even deeper into the world of ARI and its impact on the future of computing. You know, it's mind-blowing to think that something as seemingly simple as tuning how devices are addressed can have such a ripple effect throughout the entire computing world.
It really speaks to the interconnectedness of technology.
Right.
ARI isn't just a standalone innovation.
Uh-huh.
It's woven into the very fabric of PCI Express,
Okay.
influencing how other technologies evolve and pushing the boundaries of what's possible.
Okay, so ARI is more than just a cool feature.
Yeah.
It's shaping the direction of the whole PCI Express ecosystem.
Right.
That's pretty impressive. What are some examples of how ARI is influencing other technologies?
Well, one of the most prominent examples is its relationship with SRIOV,
Right.
which we discussed earlier.
Right. Single root I/O virtualization.
Yes.
That's the technology that lets a single physical device be carved up into multiple virtual ones, right?
Exactly. And ARI is essential for SRIV to work effectively.
Okay.
It provides the foundation for creating those numerous virtual functions,
Uh-huh.
which are the heart of SRIV.
Okay.
Without RIV would be severely limited in its ability to virtualize devices and allocate resources.
So ARI is like the bedrock upon which SRIOV is built.
Yes.
It's fascinating to see how these technologies depend on each other,
Uh-huh.
and how ARI is enabling this whole new level of virtualization.
And it goes beyond just SRIOV.
Okay.
RRI also enhances the capabilities of multifunction devices in general.
Okay.
These are devices that can perform multiple functions, like a combination network and sound card, for example.
Oh, that's right. I remember those from back in the day. It was always cool to have one card that could handle multiple things.
Well, ARI takes that concept to a whole new level.
Okay.
It allows these multifunction devices to support even more functions,
Uh-huh.
increasing their flexibility and utility.
So ARI is like a force multiplier.
Yeah.
Amplifying the capabilities of existing technologies and pushing the boundaries of what's possible.
It's really quite remarkable. And this interconnectedness between ARI and other PCIe technologies raises some interesting questions about the future of PCIe itself.
Yeah, that's a great point. How do you see ARI shaping the evolution of PCIe? What kind of new possibilities do you think it will unlock?
Well, one thing is for sure, ARI is going to continue to play a key role in driving the development of high-performance computing, cloud environments, and virtualization.
Okay.
As the demand for faster, more efficient, and more scalable systems continues to grow. ARI will be there every step of the way, helping to push the boundaries of what's possible.
That's exciting to think about, but it's also a bit mind-boggling.
Yeah.
It's hard to wrap my head around all the potential implications of this seemingly simple change in how devices are addressed.
I understand it's a lot to process. But that's the beauty of technology, isn't it?
Yeah.
It's constantly evolving, surprising us with new possibilities and challenging us to keep learning and adapting.
I guess that's what keeps things interesting. Speaking of interesting,
Right.
there's another aspect of ARI that we haven't touched on yet.
Okay.
Its relationship with security.
Ah, yes. Security is always a hot topic.
Right.
And ARI actually plays a significant role in enhancing the security of PCIe systems.
Okay.
When combined with Access Control Services, or ACS-ARI, can help prevent unauthorized access and data breaches.
Okay, security is definitely important. Tell me more about how ARI and ACS work together to protect our data.
Imagine ACS as a security guard at the entrance to a building, checking credentials and making sure only authorized personnel can enter.
Okay, I can picture that. So ACS is the gatekeeper, but where does ARI fit into this security picture?
Well, ARI provides more granular control over access to individual functions within a device.
Okay.
Remember, ARI allows for up to 256 functions per device.
Right, those are like the individual rooms or offices within the building.
Exactly. With ACS and AII working together, you can restrict access to specific functions based on user roles or security clearance.
So it's like having security checkpoints within the building,
Yes.
controlling access to specific rooms or departments. That makes a lot of sense.
Uh-huh.
It adds an extra layer of protection.
Precisely. For example, in a virtualized environment,
Right.
you might have a virtual machine that only needs access to a specific subset of functions on a network card.
Right. It doesn't need access to everything, just the functions it needs to do its job.
Exactly. Using ACS and ARI, you can restrict that virtual machine's access to only those necessary functions.
Okay.
Preventing it from accessing or interfering with other functions or data.
That's a really clever way to enhance security. It's like giving each tenant in a building a key that only unlocks their own apartment and maybe a few shared amenities, but not every room in the building.
That's a great analogy. This level of granularity is crucial for protecting sensitive information and ensuring the integrity of the system.
So ARI is not just about performance and efficiency. It's also about security. It's impressive how this seemingly simple change in device addressing can have such far-reaching implications.
It really highlights how all these different aspects of technology are interconnected,
Right.
and how innovation in one area can have a positive impact on other areas.
This deep dive has definitely opened my eyes to the hidden complexities and wonders of PCIe and ARI.
Yeah.
It's amazing to think that even the most mundane-sounding technical details can have such a profound impact on our digital world.
Absolutely. And it's a testament to the ongoing quest for innovation in the field of computing.
Right.
Engineers are constantly pushing the boundaries of what's possible.
Uh-huh.
And technologies like ARI are paving the way for even more powerful, efficient, and secure systems in the future.
Okay, we've covered a lot of ground today.
Yes.
From the basics of ARI to its impact on virtualization complex, topologies, high-density systems, and even security.
Right.
But there's one more crucial aspect we need to explore before we wrap up this deep dive.
Okay.
The actual implementation of ARI in real-world scenarios.
That's right. Understanding how ARI is put into practice, both in hardware and software, is essential for appreciating its full significance.
So let's roll up our sleeves and get into the nitty-gritty details of ARI implementation.
Okay.
It's time to see how this technology comes to life in the devices and systems we use every day.
We've talked about the theory.
Right.
Now let's look at the practice, starting with the hardware side of things.
Okay, hardware first. What are the key components involved in making ARI work in the real world?
As we mentioned earlier, you need PCIe switches that support ARI.
Right, those are the traffic directors of the PCIe world, making sure data flows smoothly between different devices.
Exactly. But with ARI, these switches need to be even smarter.
Smarter in what way?
Well, they need to be able to recognize and handle those extended 8-bit function numbers that ARI uses.
Okay.
Instead of just looking at the old limited addresses, they need to understand the new expanded addressing scheme that ARI introduces.
Okay.
It's like upgrading the traffic signals in a city to handle a much larger volume of cars.
So they're like ARI-aware traffic cops, making sure all the data packets get to the right destination, even with all the extra traffic. That makes sense.
And it's not just about having ARI-capable switches.
Right.
It's also about placing them strategically within the PCIe hierarchy
Okay.
to handle the increased traffic and complexity introduced by ARI.
Okay, so placement matters, too.
Yes.
It's like planning the layout of the city to optimize traffic flow. What other hardware considerations are there?
Another crucial component is the root complex, which sits at the top of the PCIe hierarchy. and manages the entire PCIe fabric.
Right. The root complex is like the control center for the entire PCIe system.
Exactly. And with ARI, the root complex also needs a major upgrade.
Okay.
It needs to be able to configure and manage ARI devices,
Uh-huh.
ensuring the system can properly identify and interact with them.
So the root complex needs to be error aware as well.
Yes.
It's like giving the control center a new set of blueprints for the upgraded city.
That's a great analogy. And of course, the devices themselves,
Right.
the endpoints, need to have ARI capability implemented in their hardware.
Right. The devices themselves need to be able to speak the language of AIR.
Exactly. This involves incorporating the necessary logic and configuration space structures to support ARI functionality.
Okay.
It's like giving each building in the city its own unique address based on the new system.
Okay, so it's a collaborative effort involving all these different hardware components working in sync. It's like a symphony of hardware, each instrument playing its part to create the beautiful music of ARI.
That's a wonderful way to put it. But the symphony doesn't end with the hardware.
Right.
We also need the software to conduct the orchestra.
Right. The software is the conductor, bringing all the different instruments together and making sure they're playing in harmony.
Exactly. And on the software side, the first thing we need are ARI-aware device drivers.
Okay, device drivers, those are the little pieces of software that allow the operating system to talk to specific hardware devices, right?
Exactly. And with ARI, these device drivers need to be updated to understand those expanded function numbers.
So they need to be able to speak ARI.
That's a great way to put it. They need to be able to treat each virtual function as if it were a separate physical device, even though they're all part of one physical device.
Right.
It's like teaching the interpreters a new language so they can communicate effectively with the newly upgraded buildings.
That makes sense. What other software components need to be updated to support ARI?
Well, if you're using virtual machines, which you probably are if you're taking advantage of ARI,
Right.
then your hypervisor also needs to be ARI aware.
Right. The hypervisor is the software that manages all the virtual machines, making sure they have the resources they need.
Exactly. And with ARI, the hypervisor needs to understand how to allocate those virtual functions to different virtual machines.
So it's like the hypervisor is the city planner deciding which residents get to live in which apartments within those expanded buildings.
That's a perfect analogy. And lastly, your operating system itself needs to be updated to support ARI.
Okay.
It needs to be able to recognize devices with extended functions and manage them accordingly.
Okay, so it's a whole ecosystem of software working together to make ARI a reality.
Absolutely. The hardware provides the foundation,
Right.
but it's the software that brings it all to life and makes it usable for everyday applications.
It's incredible how much coordination is required across all these different layers of technology to make something like ARI work seamlessly.
It's a testament to the ingenuity and collaboration of engineers across the entire computing industry.
Are there any challenges or complexities involved in implementing ARI? It seems like there are a lot of moving parts that need to be perfectly aligned.
You're absolutely right. Implementing ARI is not without its challenges.
Okay.
One of the biggest hurdles is ensuring compatibility across different hardware and software components.
That makes sense. Not all devices and systems support ARI yet, right?
That's correct. ARI is a relatively new feature,
Uh-huh.
and it takes time for the entire industry to adopt new standards and update their products.
Right.
So one of the challenges is making sure that all the pieces of the puzzle fit together,
Okay.
from the PCIe switches and root complexes to the device drivers, hypervisors, and operating systems.
Right.
It's like making sure all the different parts of a car are compatible and work together seamlessly.
So it's like building a car where all the parts come from different manufacturers, but they still need to work together perfectly.
Right.
That sounds like a recipe for a headache.
It can be, for sure. But the industry is working hard to make the transition to ARI as smooth as possible.
Okay.
The PCI SIG, the organization that governs the PCI Express standard, is actively developing and promoting specifications and guidelines to ensure interoperability and ease of implementation.
Okay, so there's a lot of effort going into making ARI a success. Are there any other challenges besides compatibility?
Another challenge is managing the increased complexity that ARI introduces.
Okay.
With more functions per device, there's more to manage and configure.
Right.
This can require more sophisticated software tools and potentially more overhead for the system.
So it's like having a much larger house to manage.
Yes.
More rooms to clean, more appliances to maintain, more things to keep track of.
That's a great analogy. But despite these challenges, the benefits of ARI are clear.
Right. We've talked about how ARI enables virtualization, improves performance in complex topologies, makes high-density systems more efficient, and even enhances security.
Yes.
It seems like the benefits outweigh the challenges.
I definitely agree. And as ARI continues to evolve and mature, we can expect to see even more innovative applications and benefits emerge.
That's exciting. It sounds like ARI is just getting started.
Absolutely. The world of PCIe and ARI is constantly evolving.
Uh-huh.
Keeping up with the latest developments and understanding the interplay between these technologies is crucial for anyone working with or interested in the future of computing.
This deep dive has definitely been a whirlwind of information.
Yeah.
It's amazing to see how much ingenuity and engineering goes into making our computers work seamlessly, even at the most fundamental levels.
It's a constant reminder that technology is always evolving, and there's always something new to learn and explore.
Right.
And ARI is a perfect example of that.
Well said. Now that we've covered the theoretical foundations of ARI and the practical challenges of implementing it, I'm curious to see how it all comes together in specific real-world applications.
Okay.
Can we dive into some specific examples of how ARI is being used in different industries and devices?
Of course, let's start with one of the most prominent examples.
Okay.
Data centers.
Okay, data centers, those are the massive server farms that power the internet and all our cloud services, right?
Exactly. Data centers are all about efficiency and performance. They need to handle massive amounts of data and traffic.
Right.
And they need to do it quickly and reliably.
Yeah.
ARI is a game changer for data centers because it allows them to squeeze more performance out of their existing hardware.
So ARI is like a secret weapon for data centers, helping them keep up with the ever-increasing demands of the digital world?
Precisely. One of the key ways ARI is used in data centers is to enable something called network function virtualization, or NFV.
Okay, network function virtualization. That sounds like a mouthful. What exactly is it?
NFV is all about taking traditional networking functions,
Okay.
like firewalls, routers, and load balancers, which used to be implemented in dedicated hardware appliances,
Okay.
and running them as software on virtual machines.
Ah, so it's like taking those physical boxes and turning them into software that can run on any server.
Exactly. This has huge advantages for data centers.
Okay.
It makes their infrastructure more flexible, scalable, and cost-effective.
Right, they can spin up new network functions on demand without having to buy and install new hardware.
Exactly. And ARI plays a crucial role in enabling NFV by providing the necessary virtualization capabilities.
Okay.
With ARI, data centers can create multiple virtual network functions on a single physical server,
Okay.
each with its own dedicated resources and performance guarantees.
So ARI is like the foundation for NFV.
Yes.
Making it possible to virtualize those essential network functions.
That's a great way to put it. And NFV is just one example of how ARI is being used in data centers.
Okay.
It's also being used to enhance storage virtualization, GPU virtualization, and other key technologies that are essential for modern data center operations.
Okay, so ARI is a multi-talented performer in the data center world. What about other industries? Where else are we seeing ARI making a difference?
Another area where ARI is having a significant impact is in the field of artificial intelligence, or AI.
AI, that's the technology that's powering all those cool things like self-driving cars, personalized recommendations, and voice assistants.
Exactly. AI is rapidly evolving, and it's becoming increasingly demanding in terms of computing power.
Right.
AI is helping to meet those demands by enabling more efficient and scalable AI infrastructure.
Okay, so ARI is playing a role in the AI revolution. How exactly is it contributing to advancements in AI?
One of the key ways ARI is being used in AI is to enable more efficient training of deep learning models.
Okay.
Deep learning is a type of AI that involves training artificial neural networks on massive data sets.
Right, those are the algorithms that are getting really good at things like image recognition, natural language processing, and game playing.
Exactly. And training these deep learning models requires a lot of computing power, especially GPU power.
Right.
ARI helps to make that training process more efficient by allowing multiple AI workloads to share a single physical GPU.
So it's like giving each AI model its own personal slice of GPU power.
Exactly. This allows for faster training times and more efficient utilization of expensive GPU resources.
Okay.
It's a win-win for AI researchers and developers.
Okay, so ARI is helping to accelerate the development of AI by making the training process more efficient. That's pretty cool. Are there any other ways AI is being used in the AI world?
Absolutely. AI is also being used to enhance the performance of AI inference,
Okay.
which is the process of using a trained AI model to make predictions or decisions.
Right, so training is like teaching the AI model, and inference is like using that knowledge to solve real-world problems.
That's a great way to think about it. And ARI can help to make AI inference faster and more responsive by enabling more efficient sharing of GPU resources and by reducing latency in data transfers.
Okay, so ARI is improving both the training and inference aspects of AI. It's really becoming clear just how versatile and impactful this technology is.
It's truly remarkable, and these are just a few examples of how ARI is being used in real-world applications. As the technology continues to evolve and mature, we can expect to see even more innovative and exciting use cases emerge in various industries and fields.
It's an exciting time to be following the world of computing.
Yes,
And ARI is definitely a technology to keep an eye on.
I couldn't agree more. ARI is a testament to the ingenuity and creativity of engineers who are constantly pushing the boundaries of what's possible with technology.
You know, as we've been exploring ARI, one thing that keeps striking me is how much it highlights the importance of collaboration in the tech world.
I couldn't agree more. ARI is a perfect example of how innovation often happens at the intersection of different technologies and different players within the tech ecosystem.
Right. It's not just one brilliant inventor working in isolation. It takes a whole community of engineers, developers, and companies working together to make something like ARI.
Exactly. And one of the key ingredients in this collaborative process is the establishment and adherence to standards.
Standards, like rules everyone agrees to follow. Why are those so important in the tech world, especially when it comes to something like ARI?
Think of standards as a common language that everyone in the tech industry can speak.
Okay.
Without a shared language, communication would break down and things wouldn't work together properly.
Okay, that makes sense. So standards are like the glue that holds the tech world together, making sure everything can communicate and interact smoothly.
That's a great analogy. And in the case of ARI, standards are essential for ensuring interoperability,
Okay.
the ability of different devices and systems from different manufacturers to work together seamlessly.
So thanks to standards, I can have a computer with components from different companies, and they'll all play nicely together because they're speaking the same language.
Precisely. And this interoperability is crucial for fostering innovation.
Okay.
When everyone is working from the system playbook, it allows companies to focus on developing new and innovative solutions without having to worry about compatibility issues.
So standards are like the foundation upon which innovation can flourish. They provide a stable base for companies to build upon.
Exactly. And in the case of ARI, the PCI SIG, the organization responsible for the PCI Express standard, plays a crucial role in establishing and maintaining the standards that ensure ARI's interoperability and widespread adoption.
It's amazing to think that something as seemingly mundane as a standards organization can have such a profound impact on the evolution of technology.
It's a testament to the power of collaboration and the importance of working together to advance technology for the benefit of everyone.
Well said. This deep dive has been a real eye-opener, revealing the hidden complexities and interconnections that drive innovation in the tech world. It's like we've peeled back the layers of an onion, uncovering deeper and deeper levels of ingenuity and collaboration.
That's a great analogy. And I think one of the key takeaways from our exploration of ARI is that innovation is rarely a solo act. It's almost always a team effort involving a diverse group of players who are all working towards a common goal.
Right. It takes a village to raise a technology, so to speak, and ARI is a perfect example of how a collaborative approach can lead to groundbreaking advancements that benefit everyone.
I couldn't agree more. And as we wrap up this deep dive into ARI, I think it's important to remember that this is just one example of the incredible innovation that's happening in the world of technology every single day.
That's true. There's always something new and exciting being developed, and it's up to us to stay curious, keep learning, and embrace the transformative power of technology.
Well said. And for those who want to delve even deeper into the world of ARI and PCI Express, I highly recommend checking out the Understanding Alternative Routing ID and PCI Express document we've been referencing throughout this episode.
Right.
It's a bit technical, but it's packed with valuable information and insights.
Absolutely. It's a great resource for anyone who wants to get under the hood and really understand how ARI works. And who knows, maybe our deep dive has inspired some future engineers and innovators who will take ARI to even greater heights.
I hope so. The future of technology is in the hands of those who are curious, passionate, and willing to push the boundaries of what's possible.
Well, on that inspiring note, I think it's time to wrap up this deep dive into ARI. Thanks for joining us.
It's been a pleasure. I hope you'll join us again for more deep dives into the world of technology.
Until then, keep exploring, keep learning, and keep innovating.